Okay, assalamu alaikum. Bismillahirrahmanirrahim. We are going to have an assembly modeling tutorial today for SolidWorks, inshallah. And in the assembly modeling, the first step which you have to do is to sketch on paper what is your assembly idea going to be. As given in your lab assignment, you're required to make a container or a garbage container which has two inside compartments and some wheels and a cover, right? Right now, this idea is in my head. The first thing before even opening SolidWorks is you need to take a piece of paper and try to sketch what the idea is and how you are going to make it. Because if an assembly has different parts, in this case we have 4 parts, it will be difficult to join them unless you design how they will going to be fixing together. So the first step in making assembly is actually to sketch it on the paper. Okay, that's the first step. And then the second step in the assembly is you will go ahead and design individual parts. So if you have a wheel, you will design separate. You will have a cover separate, the main container box separate, and then the inside buckets separate. You will design them as a normal part file, which you already have practiced in the previous labs. Then the only thing you need to take care about how they will fit together, and this you need to think while you are sketching on paper in the first step. In the another important point, very important point, is you need to first create a folder on your desktop or any folder you're working in, and then start saving all the parts files in that folder. Okay, otherwise it will be very difficult to find the things from here and there, and especially when you join them in an assembly, all the parts should be in one folder. Very important point. After you have done the individual parts, you can just simply import them one by one in assembly mode of SolidWorks, and then define something called mates. Mates is it means connections between different parts. Okay, and then these contacts and relationships, you need to make sure they are in the same way as the actual function. If something is rotating, it should rotate. If something is opening and closing, it should open and close. And the last thing which will help you in your assemblies is it's better to have color coding on the parts. So each part should look different, because in SolidWorks everything appears to be grayish, bluish color. So it's better to have different colors on the parts. Okay, simple. I think you got the idea. The first step is you will sketch what we are going to make in assembly on a piece of paper, normal piece of paper. Okay, so here I have from our assignment. Actually, I'm going to make the same as what we have in our assignment. Okay, I asked from you to make a container with 2 buckets, wheels, and the top cover, right? This is the requirement of assignment. So it has actually 4 parts. So what I did in the beginning is the first thing I did is I sketch in my mind. I know as bad as your my sketching is, it can be worse than that. But to keep an idea how we are going to join things together, it's good to sketch on paper. So I want you to focus here on the picture on the left here. This is my first try. I think I'm going to make this. And the assignment for this lab is 3% of your course. It is going to test how creative your group is. So this is the most basic example which we are going to draw today, but it can go beyond and explore different things in SolidWorks also. Okay, so what my assignment is I have a base container, which is this one. Okay, it has I just made for myself some handle here on the right side, and then I made a wheel here and a wheel here, and I decided to keep the front without wheels, so it's just some support here. And inside I have 2 empty compartments, and this is where the buckets are. And I have a top cover here which looks something like this, and this is some round areas which will act as hinges. Okay, this is my idea. Now let me decide. In this case I have here my box container with the compartment here and here. Now let me break it down. I have broken it down into 4 parts, 1, 2, 3, and 4 here at the bottom. So what are my 4 ideas? So my first part will be the frame. Okay, so this is the frame. I think I would make something like this in SolidWorks. Okay, I don't maybe while designing I will change, but this is my idea before even opening SolidWorks. Okay, I have here a box, of course. This box dimension. So first I keep an idea of how I will design it. So I have kept one area here for attaching handle or making handle, another area for handle, another area for handle. I don't know how I will make this. I just make a square. Here at the back corner, on the back side, both sides, only at the back, I have made a hole to put the wheels. Okay, this is my idea. I have to make a hole in my part before bringing the wheel, because how the wheel will attach. So here I have made a hole. Now how much size, this I will decide later in the second step. And then on the top here I will cut 2 spaces for buckets. That's it, simple. And then in the front, I decided not to put the wheels, but I will put these stoppers and supports. Front foots, it says front foots. From the given lab criteria, I have to stick within these dimensions, so I kept it like this. So this side I will make it 1000, this side I will make it 800 millimeters, and this side 1200 millimeters. And this inner box I will cut according to part number 4, which is the inner buckets. I didn't decide yet how much it's going to be in size. Okay, for sure it will be less than these limits of the outer container. And then here, this is the most important thing I want you to focus. I also planned to keep the side hole to be 50 millimeter hole for the wheel shaft. If you know, guys, the wheel is a tire, and then there is a shaft from the tire which will attach inside the axle or somewhere in the gearbox. So I have to make a hole here which should be 50 millimeter. This is my idea. Next, I have a top lid. This is a simple part. I have decided to keep it the same dimension as box and make 2 handles on it. This is what my idea is. You can make it the different design, a circular one or something, but to keep it simple, this is my second part. And for that, my dimensions will be 1200 by 1000. And I have kept the thickness to be 50 millimeter, yani the depth of the cover. And then what I will do is I will cut here inside so that I have the thickness of my sheet to be 10 millimeter only. We use a feature in SolidWorks called shell. If you click on shell and put 10 millimeter, what SolidWorks will do is make it cut inside the top lid and leave a thickness of 10 millimeter only on the sides. Okay, this is my idea. So 2 parts up to now. I think everything is clear. I have the main container which I will make part number 1. Part number 2 is lid. Part number 3. So only the part number 1 was the most complicated one. Part number 3 is just 2 wheels with shaft. Okay, I will make only 1 wheel and we will bring it 2 times. So here it's how it will look. And to fix the dimension, guys, I have decided to keep my tire to be 200 millimeter in diameter, and the shaft, remember, is the same as the hole I will make in the part number 1. So this is how you should make the connections in your mind, how my things will touch together. And this is the designer's thinking. And that's why we are sketching actually on paper before going to SolidWorks. So here I have 50 millimeter shaft. This will go where? This will go inside the hole here, on top here, if you remember. Okay, 3 parts. Alhamdulillah, everything is clear so far. And the last part, which is the inner buckets, I will just create a rectangular container. So it's inner bucket with handles, and I will make 2 handles here. All I need to make sure is that the total length is not exceeding the inside of container number 1, okay, or the frame. And then for the dimensions, I have kept it to be 800 in height, 600 in depth, and 400 wide. I need to make sure because there will be 2 of them. So 2 of them should fix in my part number 1. So here I have 2 of them here and here. Just need to make sure my side dimension is 600 and here my side dimension is 800. So hopefully it will fit inside that, leaving 100 and 100 on front and back. This one is 800. I have here 1000. So also it will fit. And the side is 400. I have 1200. So I need to put 2 side by side. Maybe we'll keep it in the center. Okay. So this is the overall idea sketching before going to the assembly modeling. Okay, and now what we will do is we will go to SolidWorks part mode and make each one of them one by one. Coming over to making the assembly, and the first step we should do always is to right click on your main folder, click on new and click on folder. Once you have the folder, it's important to note down that you need to create everything in one folder. Okay, so I will just write here SolidWorks Lab 3 underscore practice. Okay, and now all the files which I am going to save, each one of one, I should save it in this. So let's come back to our program, click on file, click on new, and we will go to this assembly mode after we have made all the 4 parts. Okay, and first we'll go to part mode, click OK. It will open up the part mode. So now let's start again. So we are going to make the part number 1. How I plan to do it, let me start by making it on the top plane. I would love to make it on top plane. If I right click and sketch on top plane, and then here I have my top plane. I forgot to change my unit, so let me fix it now. Let me fix it to millimeters. Okay, the program takes me out of the sketching mode, so I'll go back, right click and sketch on the top plane. After that, I have to choose the center rectangle. I like to keep all the sketching, every part, everything in the center. So let me take the center rectangle and start building it from here onwards. And here I have my rectangle. So let's give its dimension according to my idea. So it is 1200 on this length side, 1200. Click OK. As simple as it is in my idea, because now I have sketched it, it's easier for me to design and no need to think about it that much. I have my design ready on paper. Why bother thinking so much? So this should be, if it is a top plane, it should be 800 because I am looking from the top on this box. So once you are happy with your dimensions, you can simply, without exiting the sketch, so now this is a shortcut, you can click on features and click on extrude. By default, the program will take this last open sketch as the sketch to extrude. So this one, in this case, I should stick to 1000 according to my sketched idea. The dimensions can vary from your assignment, as I'm doing this only for your practice. So here I have my first 1000 by 1200 by 800 box. So now once the box I have, I think the second feature I would like to get rid of first is the 2 foots here in the front. So what I will do is I will just rotate my view a little bit, go down at the underneath, and I will just create 2 footing here. So I will highlight this area, go to sketch and choose corner rectangle, and I will just simply sketch 2 rectangles. In this case I am doing it without dimensions, guys. I would strongly recommend not to do it. Everything should be dimensioned fully, perfectly and evenly. So I've just sketched 2 squares here, and then I will go to features, go to extrude, and this time let's extrude this to be around let's say 50. I want to see how 50 looks like. So 50 will look like this, and it's a little bit shorter, so let me make it around 150. I should design according to my outer limits given in the assignment. Okay, so no, 150 is too much now, so let's stick to 100. Click OK, and I have my 2 footing ready for the container in the front, if you can see here. Now what's remaining, I have this one hole I should keep at the side. So let's decide. On this right side, let's make a hole. So I'll just click on this area, go to sketch and choose my circle. And we should ideally, while sketching your idea, you should also decide where should be the location of that circle or the hole. So let me fix my view to be normal too, so I can see this in front of me. And to be honest, let's just keep it somewhere at the corner like this. and let me see how much bigger is my 50 hole size, and according to that I will place it. So let me fix my dimension for the circle to be 50 millimeters. Okay, so if you are happy with this, it's good to fix its location. So let me just fix its location from here to be also let's keep it also 50 millimeters apart also. And also let's give another dimension from the circle to the bottom edge here, and this should also be 50. So to keep things simple, I just kept everything 50 50 50, and it's just a small hole which will be the contact point for the shaft of the wheel. Okay, remember, so this is 50 by 50 hole here. After we are happy with the sketching, I just need to go to features and go to extrude cut. Now how much I should go inside, you can decide because you're the designer. I usually keep it around 10 millimeters to, because the idea of this hole is to locate the shaft only at this point. So let me just extrude it maybe 50, or because my shaft, you can see this one, the length of this shaft should be enough so that it goes inside the hole as well as it comes out a little bit. Let's continue. So here I don't want to go so much inside that it will create a big hole in my container. So what I will do is I will just go a little bit deeper, maybe 50 and that's it. So click OK. So remember, now since we make this 50 in our sketching idea, here this shaft should be more than 50, so the wheel does not touch the side of the container. Okay, this shaft should be more than 50, so maybe the length of this shaft should be 100, while the diameter will still be 50. So once you are happy with this 50 millimeter cut size, you just click OK, and I have a hole here where I will fix my wheels. I need to create another one on the other side. So let me show you a feature. It is called mirror. So go to features, click on mirror. Mirror will repeat the same feature on the opposite side. So click on mirror. In order to execute mirror properly, you need to choose a center plane. So what's the center plane? Let's check. In this case, the center plane is not top plane, is not front plane, it's the right plane. And this is the benefit of designing your model in the center. So I will choose right plane. He will ask me which feature I want to mirror. I want to mirror the feature which I just created, which is extrude cut. So click on that feature. You will see it will show a preview of how it will come here. If you are happy with that, just click OK. And then I have the same hole mirrored on the other side. In this case, I didn't need to make the sketch again. That's the benefit of using mirror command. Okay. So after making the two holes, the next thing I have here is the holes for container. The size of that will be decided by the part number 4, which is here. So let's choose the top plane, and then I will just make two holes here deep enough so that it will contain the two buckets. Okay, so right click on the top face and you can choose sketch from here, and then once you choose sketch, you can click space bar and click normal too, so it will come in front of you. Now I know that this is the top view of my garbage can or the container. So let's draw two horizontal rectangles the same size as the container. So I will take it from the center, go roughly here in the center, and draw roughly a container. Now my dimensions will decide if this is going to be the same as I want or no. So let me start giving a dimension. So I want this to be, sorry, click on smart dimension and choose this edge to be dimensioned. So here, this one, in my case here, I have 400 millimeter wide. So let us make it also 400 millimeter wide. Or if you want to leave any clearance, you can leave it. It's up to you. Okay. So let me change it. So here I will choose this to be 400 millimeters. Click OK, and the sides to be now you are seeing it's going towards the center. The sides to be 600 millimeter as it is here. Okay, It is up to you guys. There's many things, because you're the designers, there's many things you can change and play around to make your design even better, look attractive, or anything. So now I have 600 here. Did you see how this point moved from the origin? So to keep it center, you can just click on the center of this rectangle and the origin here, control, and then this button. So the two are selected. Once both are selected, you can click on this button called horizontal, and they will be side by side with each other. And just to show you another feature, I can also mirror this on the other side. For that, I need to create a center line here. So what I will do is I will just sketch a straight center line here. Okay, just make sure it's straight. And I want to use mirror command in the sketching. So remember, this is different from features. This is mirror command in sketching. So he asked me, what do you want to mirror? So I want to mirror these things. Okay, the 4 lines here. Good. Then what is the mirror center plane? It is the new center line which I developed, and you can see the other sketch came automatically. Once you're happy, click OK. And then you can play around, make them exactly in the center as you like it. But to skip and to make things early, let's be content with what I have, 400 by 600, as long as it's coordinating with my bucket size. And then you can just go to features, extrude cut, and it will cut the buckets inside my original part, which is the base or the frame. I call it frame. So it's this depth of cutting enough? No, we should have 800 and a little bit more for the handles. So let's keep it around 900 millimeters, as we have 1000 as the height, so it's okay. So let's keep it around 900 and click OK for that. So now here, I think this is all we need to create in the part number 1, which is the frame. So let's fix the view properly, and this is all I have in the part number 1. If you want to do any changes, you can do later on. If you add any fillets, it's good to add. But for the assembly, my part number 1 is ready. One last thing I want to do always before doing and saving this one is to right click on the part and change its appearance. So let's change this part's appearance to be a color different from the other parts, so that it's easier to recognize it in the assembly. So I have clicked on appearance, and let's choose a dark green or some color of this sort. So let me choose this color and click OK. So in this case, you can also, so once you're happy with that, you can also apply material if you like. But let's keep things simple. So now let's click on File, Save As. So always save in the same folder which you created in the beginning, remember? So on my desktop, I have created that folder. It is called SolidWorks Practice. So let's click on that. And here I will save it as frame, which is my part number 1. If you want, you can also write it as 1_frame, so you remember which is the first part you created. So that's all in the frame part. Next, we need to proceed and create the cover or the lid of this frame. So now the second part. Before going to this one, I would like to do one thing, guys. I would like to write here what is my dimension here, so I don't forget. So if you remember this extrude cut sketch, I need to just make a note on the side that this 2 squares were 600 by 400. So 600 by 400, and from the center in the origin, because the lid we need to make sure it is within that. So let's try that again one more time. Close it, and then we will open a new part. So click on, once it's closed, click on File, click on New, and then we will choose Path, click OK. And remember, guys, keep all the units consistent within all the group members or all the designers, so things are easier to join. So I will not forget this time. Let me change my units first to millimeters. And if you remember, I created the first part on top plane, so let me also create the top cover on the top plane. So right click top plane and sketch. And to keep things simple, we will keep the dimension same as the bottom bottom as the frame, as the main part, which was part number 1, frame. So let's choose center rectangle, and we will draw the center rectangle here. And the next is we will give its dimension the same as my dimension for the frame. Okay, so let's give this one 1200 in this case, 1200. Click OK, and the side dimension should be 1000. Yes, this should be 1000. In this case, let's make it 1000 and click OK. All right, so I have 1200 by 1000 by 800. It should be 800, guys. Focus. It should be 800 because my side dimension is 800. This 1000 is wrong here. It should be 800 from the side, otherwise it will not come on top of your cover. So 1800. And then once you are happy with that, just click on features, extrude, and it will give it thickness. So here I have decided to give it 50 millimeter thickness, which will increase my overall side length to be more. Okay, remember, so because this thing will come on top of the frame part, which is the part number 1. So click on 50, click OK. I have my top cover, which is 50 millimeter. Now in this example, I have written here inner shell to leave 10 millimeter thickness. So let me show you another advanced feature of SolidWorks. I will just make it on the opposite, and from the bottom side, let me select this face, go to shell. Okay, shell option. What the shell is, it hollows out a part, leaving open faces you select. Okay, so click on shell. What it will do is you need to select the face which was already selected, and if you click on 10 millimeter, watch what happens. Click OK. What the software has done is it has left 10 millimeter from the sides and make everything inside hollow. Did you see that? So this shell feature simply allows me to remove the material according to the thickness I want. Once I'm happy with this cover, one thing I would like to add before going to the other part is to add some handles here, but it is up to you guys how you can decide. So for me, I just want to simply create simple handles or features to show that they are handles. In this case, let me just quickly sketch out some rectangles to demonstrate these are handles, but you can be creative in that and you can create actually more attractive handles. So in this case, let me create this as a handle and another sketch here as handle. Okay, so simply I'm just creating these to show that this is where the handle will be, or you can maybe cut it, put an attractive, use sweep feature to create good handles if you like. Sweep is a really good feature in SolidWorks which you can use to make handles. Once you are happy with your top lid, which is a cover, let's again give the same appearance, give this part some appearance and different color, or maybe the same as the frame, as you like it. Okay, we need to give it a different color, so let me give it maybe light green this time and click OK. So I have the top lid ready. Once I am happy, just click on File, Save As, and you can simply save it in the same folder, but this time let's keep it part 2 underscore lid, the top cover or the lid cover. So just click OK. We have 2 parts ready. Now the third part is the wheel. So let's go ahead and design the wheel. I'm going to create again file, new. Now this time we are making the wheel here. Okay, click on path, click OK. For making the wheel, I will just take so let me show you another way of making wheel. Right click on the front plane, click on sketch, and we are going to use Revolve feature to make the wheel. Okay, so it's easier just to show you another additional feature. So what I will do is I will create a line, and this line will be the half thickness of this. So that can be like this. So let me make half of the wheel. You can say this is a half of the wheel, and it should come back to the origin here. So here I have the shaft of the wheel, and this is the rest of the wheel. Now my dimensions will decide if it is correct or wrong. So my wheel diameter, I have idealized it to be 200 millimeters. Now here, did you see I forgot to change my units? So it's showing in meters. What you can also do is you can write 200 and write millimeters. Click OK. It will automatically catch 200 millimeter. And you can later on change your units to be millimeters. Okay, this is very easy to not work in the correct units. So make sure your units are always incorrect. So once I change the units, it exits the sketch. So I need to right click the sketch and click on edit again. Okay, 200 here for my wheel, and my shaft is 50. And half of 50 I should give here 25. The length of this line should be 25 here in order to be half of the shaft. And then this thing will rotate to give you the full wheel on this one. Okay, and then here this length is important, guys. If you remember, this is the length of shaft which should go in the cut hole which we created in the first part. So in order to fix that, we kept the cut hole to how much deep? It was around 10 or 50. Remember, I need to make it 100 in order to make sure my tire is not touching the body of the frame. And you can see this moved. So let's give this also the thickness of the wheel. In this case, let's give the thickness of the wheel to be 50. This is a reasonable thickness for the wheel. And this is just some things you can play around with you as you feel you think it's looking good. Yes, I have made a mistake. This should be half of 200, so it should be 100 here. If you are not sure and you need to use calculator, sometimes what good thing in SolidWorks is you can also write 200 divided by 2, and then just click enter. It will return 100 here automatically. So that's something you don't have to think extra so much. Once you're happy with your half sketch, just click on features, go to revolve. In the revolve command, guys, you need to select where the sketch will revolve around. So what is the axis of revolution? So click on this area and choose this axis. And look, the whole part is revolving. If you're happy with this, click OK. And my wheel part is ready in just one command, which is revolve. You can again add here extra cuts to make it actually look like a wheel, or you can just skip it. It's as up to you as complex you want it. For me, I will not make it more detailed. I will just simply skip to the appearance part of that, and then let me just make this whole part a different color, just so that we can differentiate in the assembly. In this case, we have chosen a dark color for the wheel from the appearance option, and now my wheel is ready. You can create as complex wheels as you want, but this is the simplest I can get. Just need to make sure this shaft will go in the original frame. So click on save as, and you need to save it as part number 3 underscore wheel, and click save. Good, alhamdulillah, we are ready for the 3 parts. Now we need to go for our last part, which is also a container here. I am planning to make extrude of this square size and then use shell command to make the container. So close this one now. Since we saved it, that's okay. And for the 4th part, let's do again, repeat the same. File, new, and then click on part, click on OK. And guys, the idea of this lab is to show you the philosophy of how you can build an assembly. For that, you need to sketch your whole assembly idea on paper before actually going into modeling that. And that's what we are exactly doing in this example. Okay, so now our fourth part here is this bucket. Let's choose again the same as what we have been doing, the front plane, but this time let's don't forget to change units, millimeter. And then again I will choose my top plane and click on sketch, and simply this is the same, repeating the same as we make the top compartment, and that is done by choosing the square command and sticking to the origin for designing it. So in this case it's 400 by 600, so let me choose the same.
Thank you.
All right, now let's give it dimensions. So in this case, my dimensions, the cross-sectional dimensions in this case are 400 by 600. So this one for me is 400. Click OK. And the one on the side is 600. As in this sketch here, the one on the side is 600. Okay, it's okay. Let's change this to 600 for the side dimension. Click OK, and now we simply extrude this. So once we are happy with our dimensions here, 600 by 400, go to features, go to extrude here on the top option, extrude to give it thickness, and here we will extrude it to around 800 millimeters. So let's choose this to be 800, because if you remember, the cut we made in the first part was 900 millimeters. So if we make it 800, we are still safe. So once you're happy with 800, click OK, and you simply have, after extruding, a container, but still not a container. We need to make a shell feature here to make it hollow inside. So you can use shell feature. Click on shell, and then it will ask you how much millimeter thickness you want. So let's keep it 10. Choose the face, the top face, and click OK. It will make the bucket hollow inside. Then you can make simply some handles on this top edge. So in order to sketch something here, you need to zoom in, choose this face, then go to sketch, go to the rectangle. In this case, I will choose corner rectangle. Now in order to sketch properly, I will press space bar and click normal too, and just make sure this is following the correct area. So let's just simply create two simple sketches for rectangle here and here. This is just to show you this is how I will make the handles. Go to features, extrude, and remember, if we extrude more than 100 now, it will become more than 900, the part 1 depth here. So make sure you don't extrude so much for the handle. So let's keep it to 50. Here is my handles for that, and then click OK. Of course, you can make the holes from the side on this handle to make it actually look like a handle. But in this case, let me keep this example simple and keep it like this. The last part is to change the color for this one, but since we have, this is the last part for us, I'm not gonna change it. Keep it like this. Click save, and because it will look different or anyway. Part number 4 underscore buckets. Okay, bucket. Click save. Now we have finished making all the 4 parts we wanted to draw, and now let's go ahead into the assembly mode, how to fix them. Let's start, guys, in the assembly mode. To start the assembly mode, click on file, click on new, and simply go to assembly mode this time. Click on this one, click OK. So in the assembly mode, if you have planned and organized your sketching from the beginning like this, you will not run into a lot of troubles because you already know how things will connect. The main thing is to bring the first part which you want always fixed and in the center. So the program automatically asks me what you want to select to bring. So remember, the first part which you will bring should be the central part which you don't want moving. Okay, in this case, let's keep the part number 1, which is the frame. So click on frame, click OK, and after some time the part will load in your mouse cursor without any clicking. So I'm not clicking anywhere. After some time I will see it in my mouse icon here. Can you see it? Now if I try to move my mouse, this part will move accordingly where you want to keep it. Okay, so in this case I just keep it anywhere and it will fix its location by clicking here. So click and it will fix its location. On my design tree on the left side, I can see my part number 1 is here. Okay, very important. Now let's zoom out, and we cannot do anything more than this in this part. All we need to do is bring the second part and define the context. So very important tip, how to bring the second part. go on top here, click on insert components. So click on insert components and choose browse here, or if it loads automatically, just choose the second part, which is the lid. Okay, let's me show you the wheel. So let's bring the part number. In this case, let's bring the wheel, because we will bring the bucket inside, then in the last we will put the lid. So wheel number 3, click open, and after some time it will load in your mouse cursor. You can see it's coming here, and by default it's coming in the correct direction. It will fix in this hole directly. But if it is not fixing or coming in the correct direction, you can right click. So before clicking the left click, you can right click, and you can rotate it in 90 degree in Y direction, or you can rotate it in Z direction as you want. Okay, so you can change it as you want according to the orientation you want. So just place it roughly near where you want it to be fixed. You cannot fix like this. So just place it near roughly like this. Click, make the left click, and then now we will come into defining how we will join this area with this area. So usually in order to fix two things together, always you need to define minimum 2 or 3 mates. Mates means connections. And here on the top in assembly mode, we have this option called mates. So click on mate, and once you click on mate, you will be given options to choose from. There is many types of mates given here. So the first mate I will choose is the concentric mast. I will make this inner cylinder concentric with this cylinder. So these are exactly in front of each other. So click on this face. So remember, I'm choosing the face here. And the second click, you can see the face 1 is selected here. The second click you need to do is this face. And you can see the two faces are concentric to each other. So the SolidWorks program automatically thought you will want concentric. So it's concentric. The two circles are having the same diameter for that. This is what it means. Once you're happy, click OK. And I will close the mate option. You can see the two circles are concentric to each other and it's nicely in its position. But watch this. If I click on the wheel and I try to move out, it is moving. You can see it is in the same center, but the wheel can go outside, inside. This is not correct. What we need to do is define another mate which will fix its position. How? I will define the coincident or touching two faces type of mate. So click on mate again. So I told you need to define 2 or 3 mates to fix it. Here coincidence mean on top of each other or touching. So let's define a coincidence mate between the inner face of this area. So you can see what face I selected, and the outer face of the shaft here. Yes, you need to play around with your mouse in order to catch the correct view. So once I selected both of them, you can see my wheel is now touching the inner face of that frame body, and coincidence mate has already been automatically selected. And then just click OK. You can see now, if I try to move now after giving 2 mates, it is not moving inside outside. I'm trying to catch and move, it's not moving. Okay, guys, I want to tell you something. The third thing you can fix in this tire is its rotation. Now you can see if I try to rotate this tire, it is actually rotating, but we cannot see because this is all the same color. If there is no different feature on that, but if I try to move it, it is actually moving. Now let's bring the same tire on the other side also here. You can also do component patterning. You can see here linear component pattern. What it does, it repeats the same component as many times as you want. But in order to have, it will repeat the component as well as its mates together. And you can also do mirror of components. In this case, we need mirror of components, but we have to define a center of the plane. So at this point, I think we don't have any. Do we have a center plane? No, my center of the plane is somewhere else, so I will not try mirror at this point. I will just simply bring the second wheel for the second time. Notice here on the left side I have now two components. Now let's bring the wheel one more time and to show you how it will attach in the assembly. So click on insert components, okay, and it should open for that, and choose the wheel one more time. It's okay to bring one wheel 2-3 times, multiple times, that's no problem. So you can see my wheel now. I need to fix it on the back side. So let me change my view by mouse to here. Now you can see my shaft is pointing the other way around. How can I change it? So the way I showed you is right click and rotate in any direction. So rotate in Y. For example, if you drop the part like this and it's not in the correct direction you want, how can you change its orientation? You have to right click on the part, and you can choose this option called move with Triad. If you click this one, there will be a guider point which you can use to rotate, in this direction. So in this case we need it like this. In addition, if you define the mates, it will fix its position automatically. Okay, you can also move it up and down. So just keep it in this way, and I want to show you how it will change its direction to make it correct itself. So if I click this face, so let's try mating one more time, but this time let's choose the coincidence mate first and see what will happen. So I will click on mate option. I will choose this face, and then I have to change my mouse to see this face here. So I will click on the inner face of the container. The two faces are coincidenced. If you can see here, I will show you. I will click OK. My mate option is done. But you can see the two faces are coincidence. They are in front, actually in line with each other. If I try to move it, you can see it's in line with each other, but I want to catch this circle with the circle inside the frame. So for that I need to give another mate. So let's give this cylinder with this cylinder inside, and now my wheel will be in its position. Click OK, and now you have successfully brought two wheels inside the assembly. Now your assembly has two wheels and the central frame. Click spacebar and click the view. Now I have the two wheels and the frame. Let's bring the third part, which is this bucket. So click insert component, and here I will show you the linear pattern, inshallah. Click on the bucket and click open. My bucket will appear here in SolidWorks. Just roughly keep it anywhere. Now, in order to fix the location of this bucket, I will ask, okay, in order to fix this rectangular box with this rectangular box, in order to fix it, let's see how many mates we need. Okay, so click on mate. For sure, for mates, you need to define the two faces touching each other. So let's choose, first, let's choose this face touching the inner face of the container here. So I will choose this face. The two faces are touching now, you can see here. The two faces are actually parallel to each other or coincident to each other. Once you're happy, click OK. Now, if I can show you the correctly here, my view, this is my correct view. Now if I try to move it, you can see it is touching the same face, but my bucket is moving left, right, and up, down. So in order to fix that also, you need to define the second face with the side with the side face. Okay, let's try to give the second mate by the sides. So I will choose this face, and I have to rotate my view and choose this face. Alhamdulillah, now my bucket looks like it's in position. Click OK, and now let's try to move it. It's not moving in this direction, it's not moving in that direction, but it's still moving up and down. How can I fix that? For that, I have to move it outside up, because I need to touch the two faces in the bottom. So now let's choose this face, and let's choose the face in this area. Once I choose this, you can see my bucket nicely comes inside the container. Once you are happy, click OK. And now this is inside the container. Once click OK. Before moving on to bring the second bucket by linear component pattern, maybe you will think, I don't want the bottom face to touch the bottom of the bucket. I want some gap in the middle. How you can give that? So in order to do that, let's delete the last mate. So how I can see my mates I have given, you have to go to design tree here, open this one, and these are all the mates which we defined. The last mate was the one where we touch the bottom of the bucket with the frame. So let's right click on this one and delete. Click yes. Once that mate is gone, you can see my bucket is moving outside. I just click it and I can bring it up, but it will not move in X and Z direction because we fixed that mate. You need to delete that also if you want to move that. But I was telling you that what if I want it not touching the bottom of the tank but a little bit up like this, so that my handle is coming out some part. So how do I do it? I will bring it out and we need to give a distance mate this time. So click on mate and choose the same two faces which you want to give the distance between. So I will choose the bottom of my bucket here, and I will choose the bottom of my frame here. Once I choose them, the SolidWorks automatically choose the coincidence mate and make them touch each other fully. But I did not want to make them touch fully, I want to give distance. So you need to come to your mate options and open this option, which is called distance. You also have something called angle if you want to give something at angle. So let's open distance mate. You can see it has 2 meters distance. That's why you can see the bucket is that up. So change it to be maybe 50 millimeter. So I write 50 mm. Press enter. You will see this is showing you a representation of how it is not touching the bottom. It is a little bit up here. But my handle is still not out. Let's increase it a little bit more. So let's change it to 0.07 meters or 70 millimeter. Now my handles are a little bit out. And if you agree with these dimensions, just click OK. And that's how I fix the location according to how much distance I want. Alright? So not necessarily always you want two things to be touching. There is a third type of mate also, guys, where you can define that you can move it up and down. For that, we need to let me show you that. So let's right click the distance mate and we will just simply edit, because I don't want to select the two faces again. It's the same two faces. So click on edit feature. So if you remember, this mate you define by giving distance of 0.7 meter. There is another option also called advanced mate here. If you open this one, what the advanced mate can do for you is it can allow you to give a maximum and minimum distance, which will mean that you can move this bucket from this distance to that distance. How? I'll show you. Here the minimum is automatically set to 0.6, but let me change this to also 1 meter. Okay, the maximum is 1 meter, and see what will happen. My maximum, this bucket can go out 1 meter and can come inside by 0.6. If you click OK, this is maximum and minimum we have defined. Now I want to see how my mate will behave. So let's try to bring this bucket up. It is going out, you can see, but it's not going out more than 1 meter, remember. And if it is going in, it is not touching the base. So that's how you can give maximum and minimum. We give these types of mate when we want to move certain items in the way I want. Okay, so that's my mate. Now, do I have to repeat the same if I want to bring the bucket one more time here and give the same mate? No, we can simply use this option called linear component pattern. So click on this one. Okay, and choose the direction you want to pattern. So I will choose this direction. Is this arrow correct? If good, no, just click on that to make it this way. So my component will pattern in this direction. Which component to pattern? So click here and click on this component. Okay, my bucket will pattern on this side. Now, how much far you want the bucket to be and how many times you want to repeat. I want to repeat only 2 times, and this should be far enough from each other so that it will fix my other compartment. In this case, since we did not define the dimensions correctly, if you remember guys, that's why it's important to know your dimensions always. So we will do this by judgment only. Okay, let's try. So here it is coming. So let me fix it until I need to see my part from the top in order to fix it. So let me see it from the top. And I think this is exactly in the center. If I increase it, it will go to the left. If I decrease it, it will go to the left. Once I'm happy with my dimension, click OK. And you will see that the same path has been repeated here along with its mate. Remember. So if I try to move this one, you can see the other one is also moving. Why? Because the mate is also repeated in the linear component pattern. If you want to move the two buckets separate from each other, then you should not use the linear pattern. You have to bring them one by one in order to execute the movement separate from each other. Okay. So now in this case, I have brought the 3 parts which I have. Now the one last part is remaining, which is the lid, which is the top cover. So let's click on insert components and bring the last part for us, which is the lid. Okay, the top cover. Click open, and after some time it will appear in your mouse cursor, and then just place it roughly around the area you want. Click OK. And here guys, I want to show you how I will give it an opening and closing mate, because I want to make this side and this side of the bucket to open and close like a normal container cover. Okay, so let me tell you how this is possible. We need to give, let's first of all put it in its position. Roughly, let's put it here, and I want to give a mate between this edge and this edge, remember, and also this side and this side, to make the things align, because since they are square, it's easier to mate these two things together. So let's start, because this is not aligning correctly. So go to mate option and let's fix it from the side first. Okay, so in the first phase I will choose this, in the second phase I will choose this and click OK. You can see now my part is actually going inside because I just fixed it from one side only. We need to fix from other sides also, but let's fix it from these edges also. So click on this edge, choose the mate option, and let's choose this line. So remember, now I am choosing edge for mating, this line and this line. The two edges are exactly on top of each other, which is coincident. Click OK. And let's try to see how my part will move in this case. Now if I try to move it, you can see the edges are always used when you want to move the parts, but can you see this is moving 360 degrees? We need to give it some limits. How we can give limits? By using advanced mates. So let me show you the advanced mate option for in this case. So we need to give a limit angle between this edge and this edge in order to make it 0 degree and 90 degree. So let's keep it in the closed position now and click on mate option. And in this case, let's give an angle between these two edges. So first I will select this edge, then the second edge I will select is the edge for the frame. Once I choose this two, you can see the software automatically is touching them, yani closing it, my container. But let's go to the advanced mate option, click advanced mate, and remember this is not distance, this is angle. Okay, so in this case let's choose angle. This is the angle option. If you open it, do you want to give 1 degree? So my minimum will be 0 and my maximum will be 90 degree. Sometimes you need to play around, press the flip option when the software is not displaying it correctly. So if you want to check what is 90, you can put the 90 here and see. So click 90 and click outside, it will go to 90. If you want to check what is 0, click 0 and check here, it will go here. And then if you're happy with this type of advanced mate, click OK. And now my container, the last part, which is the lid, is also put in place. Okay, to give you an idea what mates we used, we have all the mates given are here on the left side, and all the parts which you brought in this are here on also in the design tree. The first mate we brought is the wheel, and if you remember, my wheel can rotate. If you cannot see it here because it's colored the same, but it can rotate easily. The second mate we gave is for the buckets, but let me show you this one. If you click from here and try to open, it will open up to 90 degree. Okay, and close here. So it is because we give an advanced mate of angle. And here, if I try to catch my bucket, bring up, it is possible because we use the distance mate with advanced mate with maximum and minimum limits. Other than that, this is your container and it is ready for the engineering drawing part, which is the next week's lab. If you have any question in assembly modeling, let me know. This is the most simplest assembly example I gave you. I want you to explore different options inside to make it more attractive, maybe make the edges curve and smooth and add more handles, more wheels and rotating wheels. It is up to you how you want to be creative. The minimum requirement for the assignment I explained in the beginning is what I have explained here in the lab exercise. More than that, in order to build any type of assembly, guys, you need to always consider your assembly idea in a sketching form first and decide on what are the components, how they look like, how they join together, and what can be their rough dimensions. After sketching, yes, you can change and make anything more improved also, but if you have sketched the idea in the beginning, it will help you in the assembly modeling. I hope you understand this tutorial for the assembly modeling. If you have any question, please let me know. Otherwise, we are finished for this lab session. Thank you.